Question is, if g of x is a piecewise defined function defined in the following way: x minus 1 over x squared minus 1 if x does not equal 1, and if we define this at 2 if x is equal to 1. From that we want to find the limit as x approaches 1 of g of x. Okay. First we're going to go ahead and graph the piecewise function. So let me go ahead and draw an xy axis. And if we look at the x minus 1 over x squared minus 1 part, that will the denominator will factor in the following way: x minus 1 over times x plus 1. And once we cancel out our like factors, we end up with the reduced rational function 1 over x plus 1. We let the denominator equal 0, we get a vertical asymptote of -1. If we look at what's going to happen as we approach positive infinity or negative infinity to figure out the behavior of the horizontal asymptote, we will have 1 over a very big number. So that's going to approach 0. So our x-axis is going to be a horizontal asymptote. And since the x minus 1 over x minus 1 were like factors that cancel out, we're going to end up having a hole at x plus 1. And to figure out the y value of the hole, we plug in 1 into the reduced fraction, so we end up with 1/2. So this is going to have a hole at the value 1, 1/2. Okay. The graph itself, if we look at a sign chart, if we look into the reduced rational function, pick a number bigger than -1, say -2. We can see that we're going to have a negative, or the graph is going to be below the x-axis. If we pick a value between -1 and 1, for example the y-intercept, we can see that we're going to be positive. And if we pick a value greater than 1, say 2, 1 over 2 plus 1 is 1/3, which is again positive. So the graph itself is below the x-axis, above the x-axis, above the x-axis. So we have a graph that behaves like that. And also, don't forget that we've also defined the function at 1, 2. So we go up to 1, 2, where we see a closed circle. Okay. Now, in spite of the fact that the graph itself is defined at the point 1, 2, the limit as x approaches 1 is what's happening to the function as we get closer and closer to 1 from both sides. So we can see in this direction we're approaching the value 1/2, as well as in that direction we're approaching the value 1/2. So although there's a break in a function and it's defined at 1, 2, the limit as x approaches 1 of g of x is still this value 1/2. Okay. Keep in mind that it's not important that the limit be defined at the specific x value that we're approaching. The question that we're trying to ask whenever we're dealing with a limit is, as I get closer and closer and closer to a specific x value, what y value am I approaching? And that's irrespective of whether the y value is defined or not defined at the particular values that we're approaching.